Sir,
Yeah.
I have I have a question in previous assignment. Can I ask you, please, sir?
Yeah. So let's keep that for the end of the session. Okay. So when we'll end it, I'll come to you.
Okay, sir.
Yeah.
Okay,
Yeah.
sir.
Yeah. So let's start with this thing. I'm sharing my screen. Please tell me whether it's visible or not. Okay.
Yes, sir. Visible.
Is visible. Okay. Fine. So, as we have seen that the week 5 of fluid mechanics was basically based upon some problem solving on the conservation equations, then conservation of mass, momentum, and energy. That is Bernoulli's equation. So, we will try to solve few problems and few conceptual questions based on this. Fine. So, the first question is, we have to obtain the conservation of linear momentum from RTT, Reynolds Transport Theorem. Okay, so that is the first part, and the second part of this question is, what can you say about the momentum of a body if the net force acting on the body is zero? Okay, so we'll do it part by part. Let us first of all discuss the first part, that is the conservation of linear momentum from RTT. Okay, so you must know, you must have seen what is RTT, right? You have studied about RTT, right, Pradeep?
Yes, sir.
Yeah. Okay. So fine. So if I write RTT, now what is the meaning of RTT? It is Reynolds Transport Theorem, and what is the significance? It uh, is a relation between the time rate of change of a system variable with that of a control volume. Okay. So if we write RTT, it will be dV by dt is equal to ddt ddt. So the volume integral beta rho dV plus surface integral beta rho e dot the area vector. So this is the now there are some like side variants of this form, but this is in general the Reynolds transport theorem. Now for conservation of linear momentum, what will be the value of B?
M vector V.
It will be what? For the conservation of linear momentum, it will be mv, right? The momentum, the linear momentum. And what will be the beta? Beta is basically dB by dm. So B is equal to linear momentum m into V, and beta is dB by dm. Okay. So what will be the value of beta? It will be V. So simply if you replace B with mv and beta with V, you will be getting the conservation of linear momentum. Fine. So that is the first part. Now what about the second part? What can you say about the momentum of a body if the net force acting on the body is zero? So can you answer this? What can you say about the momentum of a body if the net force acting on the body is zero? Okay. What is the relationship between momentum and force?
F is equal to dP by dt.
Yeah, F is equal to dP by dt. Now it is given in the question that the net force acting on the body is zero, means this is zero. Now if this is zero, it means that dp by dt is equal to 0. If dp by dt is equal to 0, then what can you say? What about the momentum? Momentum is
Constant.
constant, means the momentum of the body is not changing. Clear? So this is the first question. So this is clear, right? This question?
Yes, sir.
Okay, fine. Let's now move to the second problem. So the second problem asks, does the amount of mass entering a control volume have to be equal to the amount of mass leaving during an unsteady flow process? Please read the question carefully. So suppose we have a control volume. Okay. Say this is a control volume, a rectangular parallelepiped is, say this is the control volume. Okay, so this is our control volume. Now the question is, does the amount of mass entering a control volume, okay, does the amount of mass entering a control volume have to be equal to the amount of mass leaving? Okay, means the mass inflow and mass outflow. Now does the mass inflow have to be equal with the mass outflow for an unsteady flow process? Please take some time and answer. Say mass inflow is mi.
Sir, I not
Yeah.
understand this
Huh?
problem.
Huh?
Sir, I am not understand this problem.
Okay. Say there is a control volume. Say mass inflow, the mass entering per unit time is mi, and the mass leaving this control volume per unit time is say m0. Okay, so mass inflow and mass outflow. Okay. Now if it is a unsteady process, if the flow is unsteady, then for an unsteady flow,
Velocity does not constant with time.
see for a unsteady, see if the flow is unsteady, okay, if it is an unsteady flow process, not only velocity, what all the parameters, the flow parameters, they are not constant with respect to time, means they are changing, right? Okay. Now try to
Yes, sir.
try to think from the point of view of the Reynolds transport theorem. So from Reynolds transport theorem, dB by dt will be equal to 0. Clear?
Yes, sir.
Yeah. Now the only thing remaining will be del rho by del t. Okay. Del t of rho dv, del t of rho dv. Now if it is an unsteady flow process, then now if the amount of mass entering per unit time is equal to the amount of mass leaving, then will there be any change of mass within the control volume during a given time period? Is it possible? If suppose within the control volume, if the mass inflow and mass outflow are same, then is there any mass which is, means is there, will there be any change in the amount of mass within the control volume? The answer is no, right? Because whatever mass is entering, that much amount of mass is also leaving. So the time rate of change of mass within the control volume will be 0. Clear?
Yes, sir.
Yeah. So for an unsteady flow process, we do not have equal amount of mass inflow and outflow. Clear?
Yes, sir.
Okay, fine. Let's now move to the next problem, which is problem 3. Now, section A and B in the pipeline. There are two sections, section A and section B, shown schematically in this figure, are at the same elevation, means their elevation is same, means their datum head ZA and ZB are same, which are at 2.5 meter above the datum. Now there is a valve which lies between point A and point B. The flow parameters at A are velocity head of 0.5 meter and pressure head of 2.5 meter, and the valve loss, the loss due to the valve is 0.2 meter. You have to find the piezometric head at B. So this is the direct application of which equation?
Bernoulli's equation.
Bernoulli's equation. So please try this and tell me what will be the answer out of these four options. Excuse me. Yeah. আমার প্রচন্ড শরীর খারাপ লাগে মাথাও তো ঘোরা।
Sir, option B, 5.3 meter.
The answer is okay. What is the answer you told? 4.8.
5.3.
5.3 answer is B. Okay. So what have you obtained? So how you have obtained the piezometric head? You have basically it is a summation of P by rho G plus V, right? Right, Pradeep?
Yes, sir.
Yeah. Okay. So let's move to the next problem. In a fluid flow, point A is at a higher elevation than point B. Okay. Point A is at a higher elevation with respect to point B. The head loss between these points is HL. The total heads at A and B are HA and HB respectively. The flow will take place from which point? Tell me. Think carefully and tell me. Point A is at a higher elevation with respect to point B. The head loss between point A and point B is HL. The total heads at A and B are HA and HB. Then under flow will take place for there are four options. If you tell me which one is the correct option.
Always A to B.
Always from A to B. Okay, let's see. So according to the question, say this is the datum, this is point A, this is point B. Okay, so this is point A, this is point B. Okay, now the total head at point A is HA, and the total head at point B is HB. Now, as we have seen that flow always takes place from a region of higher total energy to a region of lower total energy. Okay. The head loss between these 2 points is HL. Now, it is not mentioned in the question that which means whether HA is more or HB is more. Now, if suppose flow has to take place from A to B, okay. Suppose flow has to take place from A to B, then what is the meaning? HA is higher than HB, okay. HA,
Yes, sir.
yeah, HA is higher than HB. If flow has to take place from A to B, HA is higher than HB, and from conservation of energy, HA will be equal to HB plus HL. Clear? Is it okay?
Yes, yes,
Yeah.
sir.
So let us look at the first option. From A to B, if HA plus HL equal to HB, but actually it should be HA should be equal to HB plus HL. So point A is discarded. So option A is not possible, right?
Yes, sir.
Yeah. B to A. Now, if the flow has to take place from B to A, then the meaning is HB should be greater than HA, or HB should be equal to HA plus HL. So, HB is equal to HA plus HL, right? So, the correct option is
Yes, sir.
3. The option you said is always from A to B. You cannot say always from A to B because the only thing is point A is at a higher elevation. So, the total potential energy per unit weight or the datum head at A is higher than the datum head at point B, but there is nothing has been mentioned in the question regarding the total energy. But the flow always takes place from a point of higher total energy from a point of lower total energy. Okay.
Yes, sir.
So the correct option is point B. Okay.
Yes, sir.
And let us see the last option, B to A. So if it is from B to A, then HB should be equal to HL plus HA. But here this HB plus HL equal to HA means that HA is higher. So this condition is from A to B. So option D is also incorrect. Clear?
Yes, sir.
Okay. Fine. Now, a jet of oil whose relative density is 0.8 has an area of 0.02 meter square and a velocity of 10 meter per second. If it strikes a plate, normally the force exerted on the plate is how much? Okay, you have to calculate the force exerted on the plate. So please try this problem. অসুস্থ মানে আমার মাথাটা ঘোরানি ঘোরানি লাগে, মানে গরম লাগে কিরকম, মানে আমি অ্যাকচুয়ালি একটু সময়ের মধ্যে সাইকেল চালাইলাম না, এনে যে তখন সারুন করি আমি এটা নিতামও ভাবছিলাম। So basically what is force in terms of density, discharge and velocity? What is force? If you look dimensionally, then the dimension of force is mlt minus 2. Okay. Now for discharge, sorry, for density it is m l minus 3. For discharge it is l3 t minus 1, and for velocity it is l t minus 1. So these two will cancel, and you will finally get mlt minus 2. So basically rho qv, the product of density, discharge and velocity, is the force. Okay. Now in this problem, the relative density of the oil is given 0.8. So you can find density. How you can find density? Density is 0.8 into 1000. So 800 kg per meter cube is the density. The area of the jet is given, which is 0.02. So if you know the area, you know the velocity. It is given in the question as 10 meter per second. You multiply area with velocity, that will give you discharge. Okay. Now force is basically what? Rho q into v. Now the plate is held normally. It is a stationary plate. So basically rho q into v will give you the force. Is it clear?
Yes, sir.
Yeah. Okay. So next problem, it is on the total hydrostatic force on surfaces. A curved surface is submerged in a static liquid. So there is a curved surface which is submerged in a static liquid. The horizontal component of the pressure force on it is equal to, there are four options: the pressure force on a horizontal projection of the surface, the product of the surface area and pressure at the center of gravity, the pressure force on a vertical projection on the surface, and D, weight of the liquid contained between the curved surface and the liquid surface. Okay, please think carefully, and for this type of problem I always suggest you draw a problem figure and try to visualize what will be the force. So you have to determine that what is the horizontal component of the pressure force for a curved surface which is submerged in a fluid at rest or a static fluid. Okay, so let's suppose,
Sir,
yeah,
option C.
tell me. Option
Option C.
C. Okay, let's see. So there is a curved surface which is, this is the curved surface which is immersed or totally submerged in a static fluid. Okay, so this is the vertical projection of this curved surface and this is the horizontal projection. Now you have to ask, you have been asked about the horizontal component. So horizontal component acts on the vertical projection. So yes, it is option C, correct. Clear?
Yes, sir.
Yeah, fine. Now, an object weighing 100 Newton in air was found to weigh 75 Newton when fully submerged in water. You have to determine the relative density of the object. So this is a application of which principle?
Uh, Archimedes principle.
Archimedes principle, yes. So you have to apply Archimedes principle to determine the relative density of a body whose actual weight or weight in the air is 100 Newton. However, the reduced weight or the submerged weight in water is 75 Newton. So please try this problem and tell me what will be the correct answer. Let's see. The weight of the body in air is basically the density of the body multiplied with its volume into g. Okay, and when it is submerged in water, then weight minus force of buoyancy is basically equal to, sorry, weight is acting in the downward direction and force of buoyancy is acting in the upward direction. So yes, weight is higher, weight minus force of buoyancy is 75 Newton. Clear?
Yes, sir.
Yeah. So rho volume into g. This is the weight. What is force for buoyancy? Force of buoyancy is the weight of the fluid displaced. The fluid in this case is water. So rho w. Now it is given in the question that it is fully submerged in water. So if it is fully submerged in water, then the volume of the fluid displaced will be equal to the volume of the body, rho, that is v, into g is equal to 75. Okay. Now from this equation, rho w is known, v is not known, rho is not known. Okay. But this is equal to 75. G is known. So using this equation, what you have to find? You have to find rho by rho w. Okay. So if you divide all this by rho w, okay, if you divide all this by rho w, then rho by rho w, here only Vg term will be there. So this is basically, sorry, Is the idea clear?
Yes, sir.
Yeah. So what is the answer? See, there are two unknowns in this problem. One unknown is the volume V and the other unknown is the density rho. So what are the two equations? One equation is definitely this one. And what is the other equation? It is FB. Force of buoyancy is what? Rho W V into G. Now this is 100, this is 75. Then what will be the force of buoyancy? It will be, if this is 100,
25.
25. Yes. So rho W into V into G is 25. Rho W is known, G is known. So you can find the value of V. Right?
Yes, sir.
And once you know the value of V, you put the value of V in this equation or this equation. I think it will be better if you put it here because you know W, you know V, you know G. Then you can find the value of rho and you simply divide rho by rho W to get the value of the relative density. So what is the answer, Pradeep? Pradeep, hello?
Yes, sir.
Yeah. Have you calculated?
Sir, answer is basically difference. Please, sir.
Okay, let's see. Let's see. Okay, let's try to solve. So rho V G is W and sorry, the buoyancy force rho W V G is 25, right? So volume will
Yes, sir.
be 25 divided by rho W into G. Fine. Now
Yes, sir.
rho Vg is equal to 100. So rho in terms of V we can write into 25 divided by rho W into G multiplied with a G which is equal to 100. Clear? So G and G
Yes, sir.
cancels. G and G cancels. Rho by rho W is the relative density that we want to find, is equal to 100 by 25. So the answer is 4. So yes, option A, 4. Is it okay?
Yes, sir.
You can get the same answer by putting the value of rho W here and value of G here, but it will unnecessarily increase the number of calculation because ultimately all these things will get cancelled out. Okay.
Yes, sir.
Yeah. So let's move to the next problem. A hollow hemispherical object of diameter d was immersed in water with its plane surface coinciding with the free surface. The vertical component of force on the curved surface is given by Fv. So if it is a hemisphere, if it is a hollow hemisphere, then it is basically a curved surface. Okay. So uh, let's look at this problem. There is a static fluid which is water given in the question. It is water. There is a hollow hemispherical object of diameter d. There is a hemisphere. Basically, there is a hemisphere of diameter d such that the plane surface, okay, such that the plane surface of this hollow hemisphere coincides with the free surface. Okay. And the vertical component of force. So the vertical component of force is basically, now if this is a hemisphere, the vertical component of force will act on which plane? Horizontal projection or vertical projection?
But horizontal projection.
Horizontal projection. So horizontal projection will basically, it is this projection which coincides with the free surface. Clear?
Yes, sir.
Yeah. So the vertical component is basically the force that is acting on the horizontal projection. Okay, the force that is acting on the horizontal projection, and this is basically equal to the weight of the fluid that is contained by this hemisphere, right? What is the vertical force? The vertical force, see this,
By
yeah, is equal to, means this force Fv is equal to, what is this force? It is the force, the Fv, which is being the
weight
force
minus
exerted by the
balance.
fluid on this hemisphere, right? So it is basically equal to the weight. Clear?
Yes, sir.
Yeah. So if this is equal to weight, so what is weight? Weight is rho V into G, right?
Yes, sir.
Yeah. Now you can see that in the question, it is in terms of gamma. So gamma is the unit weight. So unit weight is what? Rho into G, right?
Yes, sir.
Yeah.
Yes,
Rho
sir.
into G is the unit weight gamma. So it is basically, sorry, gamma into the volume, right?
Yes, sir.
Yeah. So what is the volume of a hemisphere?
2 by 3 pi r cube.
Yeah. 2 by 3 pi r cube. Very good. So if it is 2 by 3 pi r cube, in the question it is given that the diameter of the hemisphere is d. So what will be the option? You have to simply 2 by 3 pi r cube, in place of r you have to write d by 2, right?
Sir, second option is the 1 by 12 pi d
Gamma by d
cube.
cube. Yes, very good. So this is the answer. So is it clear?
Yes, sir.
Okay, so this particular session for week 5 ends here. Now let's come to your doubt. So what is your confusion?
Sir, I am sharing question in chat box, please, sir.
Yeah, fine, fine. Or if you can share your screen, that is also fine. Can you share your screen? Can you share your screen? Acha, okay, fine. You have shared the question. An air fan has a bladed rotor of 12-inch outside diameter and 10-inch inside diameter as illustrated in figure. The height of each rotor blade is constant at 1 inch from blade inlet to outlet. The flow rate is steady on a time average basis at 230 feet cube per minute and the absolute velocity. Okay, is it a question from the ongoing assignments?
Week 3
Week
assignment.
3 assignment. Okay, fine. So week 3 submission date is over, right?
Yes, sir.
Okay, fine. Okay, if the submission date is over, then it is not an issue. The flow rate is steady on a time average basis at 230 feet cube per minute, and the absolute velocity of the air at blade inlet V1 is radial. The blade discharge angle is 30 degree from the. Okay, fine. Pradeep, let's do one thing. There is a figure as well. Can you like share with the figure this particular question? Can you send this like the question and the problem figure, because there is a figure it has been said in the question that there is a figure. So I'm sending you my I'm just writing my mail ID in the chat box. Can you send me this, mail me this question?
Sir, this figure is in assignment wrong because मतलब second दूस next problem का
Hmm.
sorry sir, this figure is not given in question.
Okay, fine.
Question.
Fine. So I will do one thing. I will just okay. Let me do one thing. Can you just mail me this question? Can you send me a mail? I'm just giving you my mail ID in the chat box.
Okay, sir.
I have given. Can you see? Hello, Pradeep.
Yes, sir.
Yeah. Have you received my mail ID?
Yes, sir.
Yeah. Yeah. Don't mute yourself. Okay, because only we two are here, so don't mute yourself. Yeah.
Okay,
So,
sir.
so you do one thing. You send me a mail. Okay. You send me a mail with this question, and I will get back to you. Because I'll get back to you via mail only. Okay.
Okay, sir.
Yeah. Because it's a big question. I'll have to draw. If the figure is not there, then looking at the question, I'll have to draw a figure, problem figure, and then it's basically a problem of this thing. Like at least have you understood like it is which conservation equation will be applied in this case?
Sir, I'm not understand this
Okay,
problem.
fine. This is basically an application of conservation of momentum, linear momentum. Okay.
Okay, sir.
Okay, so how it is
Sir,
done,
I
I'll
send.
get back to you. Okay, or maybe in the next class I will take this question, or in the session if time is there, or otherwise I will send you a detailed solution. Fine.
Okay, sir.
Okay. So you just mail me. So let's stop here.
Thank you, sir.
Yeah.